this log base a half. Log base 0.5 of 100 over 140. Get that number. I'm going to keep that on my calculator. It's 0.4854 equals 5 over h, and I'm just going to cross multiply. So that number times h equals 5, and divide both sides by that decimal. So 5 divided by, and I'm not going to round that decimal, I'm going to just scroll up and pick that exact same thing. So 5 divided by that tells me that h equals 10.3. Although it says to the nearest 10,000. So tenths, hundredths, thousandths, 10,000. So 10.3002. That's the number of hours. What's h stand for? Oh, the constant representing the number of hours in the half-life. So we lose half of our product every 10.3002 hours. And then, so now that I know that, I'm going to use that h value in my formula, and I'll determine when the mass of the radioactive substance will be 40. So I've got this. I'm waiting till this declines to 40. So it'll be 40 equals 140 times 1/2 to the t over 10.3002, and I'm going to solve. First by dividing by 140, so I'll have 40 over 140 equals 1/2 to this t over 10.3002 power. Log base a half on both sides. Log base 0.5 of 40 over 140. We'll get rid of that. And what do I do to both sides to get t all by itself from here? Multiply by that 10.3. So there's my log base 5, base 0.5 of 40 over 140. I'm going to get that answer, and then I'm going to multiply it by 10.3002, which was t equals 18.616. What does it say? The nearest tenth of an hour? 18.6 hours. Okie doke. Any questions on that? So let's jump to August number 21. This one was on a test. Should look familiar. A ball is dropped from a height of 32 feet. It bounces and rebounds 80% of the height. So I think a diagram on this one just helps you wrap your head around it. Something is being dropped from 32 feet up. It bounces and it only comes up 80% of the way, which is what? 80% of 32? 25.6. So this is 25.6. Then it comes up 80% of that way. So times 0.80 is 20.48, and so on and so forth. What is the total downward distance in feet the ball traveled up to the 12th bounce? So this one's a little tricky to wrap your head around because this is up to the first bounce. So not including what happens after the first bounce, right? But up to the first bounce, how much has that fallen by? 32. Okay? And then what is our multiplier? 0.8. And we're looking for the total downward distance. So we already know it's geometric because of the 80%. Is it a sequence or a series? Series, because it's giving you the total. So S up to the 12th bounce, and I've already defined A sub 1 is up to the first bounce, so this will mean up to the 12th bounce. Do you follow that? Okay. And your formula is given right on your reference sheet, A sub 1 minus A sub 1 times R to the N and so forth. So A sub 1 minus A sub 1 times R to the N all over 1 minus R. I'm going to check that one more time to make sure that's correct. Yes, okay. So we have everything we need. We've got a sub 1 is 32 minus 32 times 0.8 to the nth power is 12 all over 1 minus 0.8. Make sure you do your numerator first. Get that answer. Divide it by what's going to be just 0.2. 32 minus 32 times 0.8 to the 12th. I'm going to hit enter after that and divide it by, and I can put in parentheses 1 minus 0.8 if I want. I could do that in my head and just put 0.2. 149. Option 4. Okay? Truthfully, on the exam, if you really wanted to do that manually and not use the formula, you probably could get up to the 12 pounds. So it would be a little bit hectic, but. Number 22, a public opinion poll was conducted on behalf of Mayor Artiga's re-election campaign. Okay, 264 out of 550 said they would vote. That's my sample proportion, yes? So that's my p hat. 264 out of 550 is 0.48. So just based on the coincidental sample I took, 48% said they were going to vote for him. Which statement is least appropriate? There's a 48% chance that Mayor Ortega will win the election. Okay. It's just one sample, but it's, it's probably someone in the ballpark, so we'll keep that one in the back of our mind. They say least appropriate, so we're just going to pick the worst statement. The point estimate, that's your sample proportion. I've never seen them call it a point estimate before, but at least they gave us that in parentheses. Of voters who will vote for Mayor Ortega is 48%. That one's 100% true. That is the sample proportion. So we know that that is definitely fully appropriate. It is most likely that between 44% and 52% of voters will vote for Mayor Ortega. So this is giving us a interval range of what they think is going to happen. Which one is better, 1 or 3? Which one's better? Bo, I'm curious to see what you think. What is my rule? No, which one? Oh, that's because there's a double negative in that question. No, just forget the question. Which one of these statements is a safer statement? No. Right. 3, because it leaves kind of a window of error. So this is definitely more appropriate than that one. So I'm not going to pick it. And due to the margin of error, an inference cannot be made regarding whether Mayor Ortega or his opponent is most likely to win the election. It's not that an inference can always be made, right? An inference can always be made. So I hate this question. I'm going to say 4 is the most false, right? Or 1. God, this is a terrible question. How could they say that an inference can? I think those are both terrible. Nathan, tell me. Right. They didn't give it to you, but at least they're opening up the window. Correct. Right. Just to say that there's a 48% chance. This one's at least giving you a window. So that one's definitely better than option 1. But I hear what you're saying, for sure. And even in 3-2, you're correct. They're saying most likely. 1 is pretty definite. There's a 48% chance. So I do tell you with stats, definitive statements like that, just saying, this is the fact, there's a 48% chance, you want to stay away from. And then, oh God, maybe it's 1. I honestly don't. And it's as opposed to like a prediction. Yeah. I might just say I would go, I don't even know, I'm going to have to look up the answer. I think I would go with 1 just because it's so definitive, and they're saying this is what's going to happen, and there's no way you can do that. I don't love the question at all, though. Last one here, number 23. We have radicals, exponents, all kind of mixed together. If I'm raising negative 54 to the 2/3 power, I can just leave it like that for now. X to the 9th to the 2/3, power to power you multiply, so that'll be x to the 18/3, which is 6. And on the denominator, 4 raised to the 2/3 power will be y to the 8/3, power to power multiply. So when we take the cubed root of negative 54, do we know what that is? What multiplies by itself 3 times and gives you 54? I don't think there's an answer to that. We're going to have to simplify that. We'll take longer on Monday. We'll pick up with that one. You're moving on to the second part of August, yes?